Hi everybody, I'm Scott McKennie. I work in a lot of different R&D projects and solution architecture projects for for Lyn at RapidMap. I'll just go through some of the lessons learned from getting engaged in this type of process of doing the 360 data capture, and also just basic image, I guess image data collection. As we've had various types of projects around that, but in this particular one, just consider that from a physical hardware solution, there's things that you're going to have to install and set up. There's you're going to have a way of integrating hardware with the vehicle. Some people use CAN bus. There's other ways of doing that as well, which is using external distance encoders. You can plug into the speedometer directly. There's things like that you actually need to use to get accurate pulsing or accurate signals to be able to send over to the cameras and the computer to be able to start generating imagery. So there's a whole bunch of different things that mesh together there to enable you to be able to capture those images quite rapidly. So we try to capture everything at about, I think, every 5 meters, and so we set those things up. Other alternatives are very expensive systems such as our Iconyx, which is inertial based, paired with GNSS, as well as a gyroscope, and I guess you've got an accelerometer in there. And all of that is very intimately tied together to be able to help produce good pulsing or good events to be able to capture those images. And these events, the signals that we get from either the vehicle or the high precision GPS, they all get fed directly into the camera to get the camera to trigger at every one of those events, and then the computer scrapes those images down. And you'd hope that the programming language is fast enough while handling everything else in order to pull those images down quickly, as well as taking the coordinates from the GPS at the same time. So there's various things that you need to consider, which is obviously the installation, the camera, the programming language that you might be using. If there's already software pre-built, that might be better if it's got really good performance. Obviously, you want to have really good GNSS receivers. How do you make sure that the geospatial data is accurate? Well, there's a level of post-processing that has to come into play afterwards as well. There's so many different levels of that you might have to consider when engaging one of these projects. So just on that collection front, as I said, installation, configuration, setup, some of the calculations that you have to do prior to, the types of cameras that you might be picking. Some of them can be quite expensive. Some of them don't have to be so expensive. Obviously the GNSS receiver, IMUs, or the distance encoder, the DMI, if you want to go down that route. The computing power, how well, what sort of power do you have access to in that vehicle? And how grunty does the computer have to be versus how lightweight? Do you need a UPS? What's your backup power if the car drops out? Are you going to lose all your data? And then yes, there's the weather considerations as well. Is it a rainy day? You probably don't want to go out. And yeah, every 15 minutes you might have to get out of the car and clean the cameras. So yeah, we'll just move on from there. So we've got just a small video of one of our trials around the office. Alrighty. So yeah, after you've actually gone out and done the collection, you want to correct the data with some base station data if you've got some sort of relationship with well, I don't know. So maybe it's Trimble, maybe you want to set up a VRS. There's multiple ways that you can do this, but you want to try and get that geospatial data as accurate as possible, so that when you're starting to do your manual feature extraction within the application, you want that to be as accurate as possible as well, because the image is only as good as the geospatial location it's on, and then also the distance away from the camera is also going to be indicative of how accurate your actual position is. So some of the outputs that you can get from that is, you'll be able to draw imagery or derive features from that imagery. You can create AR overlays. So say if you've got WFS or a WFS that you want to plug into that almost street view type of environment, you can do that too. you can extract things manually, and you can also share the 360 Street View with others if they want to derive different types of insights from the data collection that you've performed. So yeah, the manual feature extraction component. So there's various ways of doing this. You can just draw immediately from the 360 view. You can create different types of, there's a layer manager in there. You're obviously going to want to do points, lines, polygons with Z values so that you can get the approximate height. You want to configure the forms and the form types. Usually you just want them to be as simple as possible so somebody can come back over them later. Some of you can also have autofill features in this, and in order to get to that next step for automated feature extraction, you're going to want to get a lot of examples. One of the other elements to this is that if you want to get super accurate points, lines, polygons, you can also apply a triangulation method, which is from different pictures. So we've got like 1, 2, 3 different pictures. You're drawing a singular asset. You can use a triangulation method, which we've got built into the software, to be able to draw the asset more accurately. So point, line, or polygon. You say it's a pit, you might want to drop 3 points using a particular mechanism, and then you can have that as part of your layer manager. It corrects the geospatial location, makes it a heck of a lot easier. Here's just an example of being able to, do the height of a sign. It's just a quick example of a quick draw up. You might want to open that up, fill out some details. All these forms are configurable to whatever it is that you want. You can put in height, but yeah, there's other methods of being able to autofill those forms as well. Okay, so the machine learning feature extraction. So once you've actually built up a good set of data, you're going to want to, bring all this together. You need at least 1,000 examples to start building the various algorithms. We've got an API in the back end that allows people to interact with the 360 imagery and start processing it with machine learning algorithms.